7. A sample of saturated soil has the water content of 25% and bulk unit weight of 20 knots per m. Determine the dry unit weight, void ratio and specific gravity of solids. Solution. Given data, water content of saturated soil, omega, equals 25% equals 0.25 bulk unit weight of soil, B, equals 20 kN, M3 degree of saturation for saturated soil, S, equals 1 now, dry unit weight, D, can be calculated using the following formula. Eight. Name the different forms of energy of flowing liquid. Explain the principle of conservation of energy and the relationship between hydraulic gradient line, HGL, and total energy line, TEL. Answer. A liquid while flowing with some velocity contains following three types of energy. They are pressure energy. The energy possessed by a liquid by virtue of its pressure is called pressure energy. It can be calculated using the formula PE equals P asterisk V, where P is the pressure and V is the volume of the fluid. The pressure energy per unit weight of liquid is known as pressure head. Kinetic energy. The energy possessed by a liquid by virtue of its motion is called kinetic energy. It depends on the velocity of the fluid and can be calculated using the formula Ke equals 0.5 mv2, where m is the mass of the fluid and v is its velocity. Kinetic energy per unit mass of liquid is called principle of conservation of energy. The principle of conservation of energy is also known as the Bernoulli's principle. It states that total energy of an incompressible liquid flowing from one point to another point remains constant throughout the length of flow, as long as there is no energy input or output from the system. Thus, in the flowing liquids, the sum of kinetic energy, potential energy, and pressure energy remains constant. Assumptions of Bernoulli's equation. Following assumptions are made in the derivation of Bernoulli's equation. The fluid is incompressible. Their flow is steady and continuous. The fluid is ideal, i.e., non-viscous. Their flow is irrotational. The gravity and pressure forces are only considered and other forces are neglected. Their velocity is uniform over the cross-section. Limitations of Bernoulli's equation. It is ideally applies for non-viscous fluids. It has been derived on the assumption that there is no loss of energy due to friction. It is applicable only to incompressible fluids. Bernoulli's equation is applicable only to streamline flow of a fluid. It does not take into consideration the angular momentum of the fluid. Relationship between hydraulic gradient line, HGL, and total energy line, TEL. Hydraulic gradient line, HGL. The sum of potential, Z, and pressure head, P gamma, at any point on the flowing fluid is called the piezometric head. If a line is drawn joining the piezometric levels at various points along the flow, the line so obtained is called hydraulic gradient line. B. Energy gradient line or total energy line, EGL or TEL. It is the sum of total energy head with respect to any arbitrary datum. It is the sum of elevation head, pressure head and velocity head. If the total head or energy at various points along the axis of the pipe is plotted and joined by a line, the line so obtained is called energy gradient line, EGL. The energy gradient line, EGL, is also known as total energy line, TEL. The following points are worth writing: energy gradient, EGL, always drops in the direction of flow because of loss of head. The difference between HGL and TEL is equal to velocity head, V2, 2G, EGL represent the maximum height to which water may be delivered to the consumers. Nine. What are the major causes of dampness? List the methods of damp proofing. Answer: dampness in a building is the presence of moisture in various parts of building like floor, wall, roof, etc. Following are major causes of dampness: groundwater. Moisture constantly travels through soil and may rise up into the wall and the floor through capillary action. Rainwater. Rainwater may enter the building components due to various reasons, when top of wall is not protected with impervious course like concrete. When walls are not properly treated, then rainfall moisture will enter the wall. When downtake pipes from roof are not properly fixed. When slope on the roof is not given properly, water ponds are formed on the flat roof, imperfect wall joints, improper slopes to chudger, construction joints in roof, etc. Leakage from pipes. From bathrooms, toilets and kitchen, water is drained out with different types of pipes. The pipes are joined to get required length and turns. Many times water leaks through joints resulting into moisture in building components. Orientation. Various methods of damp proofing are as given below. You have to list their name only in this question. Membrane damp proofing. It consists of providing a damp proof course between the source of dampness and building component. 10. What are the functions of septic tank? Draw a schematic diagram of a septic tank showing its main components. Answer: septic tank is a watertight chamber that receives the discharge of human waste from the toilets. It is an underground storage chamber made of concrete, masonry or fiberglass and is intends to control, manage, and treat human waste and decompose it based on anaerobic bacterial reaction where solids and organics materials reduce to liquid. Following are various function of septic tank. To separate solids from liquids, the wastewater enters the septic tank and the solids settle to the bottom, forming sludge. The liquids float to the top, forming scum. Digestion of solids. Anaerobic bacteria present in the tank causing anaerobic reaction and help to break down the solids and organic matters in the sludge, producing methane gas and other byproducts. Separation of scum, grease, oils, and lighter solids. Scum rise to. Schematic diagram of a septic tank showing its main components. Fig. Plan of septic tank. Fig. Elevation of septic tank. The main components of a septic tank are: inlet. The inlet is where the wastewater enters into the septic tank. Outlet. The outlet is where the treated wastewater leaves out the. 11. What are the major losses in irrigation canal? Explain in brief. Answer: losses of water in canals may be defined as the process in which a large amount of water is lost as it passes through the canal from the starting of the headwork to the final point where it is supplied to the agricultural field. The major losses in irrigation canal are as follows. Evaporation losses. The losses of water from irrigation canal due to evaporation phenomenon is called evaporation loss. Evaporation losses may be 2 to 3% of the total water losses in the water canal. The evaporation losses depend upon several factors such as temperature, humidity, wind velocity, area of water that is exposed to the atmosphere, etc. But the most dominant factor is temperature. On account of this, the evaporation losses are higher in summer than in winter. Seepage losses. Seepage is the loss of water through the canal bed and sides due to percolation and absorption. It is the most common type of loss and can be significant, especially in canals with poor lining. Loss mainly depends upon the following factors: the porosity of the soil, existing underground water table conditions, the existing condition of the canal system, physical properties of the water canal such as turbidity of water, amount of silt carried by the water. C. Transpiration losses. Transpiration is the loss of water from plants. 12. List the various geometric elements to be considered in highway design. What are the factors on which the stopping sight distance depends? Answer: in highway design, various geometric elements are carefully considered to ensure safe, efficient, and functional roadways movement. These geometric elements help shape the alignment and layout of the highway. The various geometric elements to be considered in highway design are horizontal alignment. Elements within horizontal alignment include tangent length, horizontal curves, transitions, curves, compound curves, superelevation, vertical alignment. Elements in vertical alignment include slopes or grades, vertical valley curves, sag, vertical curves, sight distance, cross-sectional elements. Elements in cross-section includes lane widths, the width of travel lanes for vehicles, shoulder widths, median width, crossings. C. Intersection design. Intersection design includes elements such as turning lanes, channelization, intersection angles, grade separations. D. Roadside design. Elements related to the design include guardrail, signs and signals, landscaping, parking design, etc. Stopping sight distance. SSD. The stopping sight distance is the minimum distance required for a driver to see ahead on the roadway in order to stop their vehicle safely without colliding the object. Following are various factors on which stopping sight distance depends: speed of the vehicle. The faster the vehicle is moving, the longer the SSD will need to be. Reaction time of the driver. The driver's reaction time is the amount of time it takes them to perceive a hazard and take action to stop the vehicle. The average reaction time is about 2.5 seconds. Braking efficiency of the vehicle. The braking efficiency is the ability of the vehicle's brakes to slow it down. The braking efficiency depends on factors such as the condition of the brakes, the weight of the vehicle, and the road surface, grade of the road. The grade of the road is the slope of the road. If the road is uphill, the SSD will need to be longer than if the road is level. Height of the driver's eye. The driver's eye height is the distance from the ground to the driver's eyes. The higher the driver's eye height, the longer the SSD will need. 13. Prepare a specification for plastering work in exterior wall in cement, sand, mortar. 1:4. Answer: specifications for plastering work should be clear and comprehensive to ensure the quality and durability of the plaster. The specification for plastering work in exterior wall using a cement sand mortar mix. 1: For scope of the work. This specification covers the requirements for plastering exterior walls using a cement sand mortar mix. 1:4. At the construction site. Materials: cement. Use fresh Portland cement complying with relevant local standards and tests. Sand. Use clean, sharp, and well-graded sand that meets local. D. Mixing. Mix the cement and sand thoroughly in the specified proportion. 1:4. Until a uniform dry mix is achieved, add water gradually and mix to attain a workable consistency. Do not use excess water. Application. Apply a scratch coat to the prepared surface with a thickness of approximately 10 to 15 mm. After the scratch coat has set but is still green, apply the finishing coat with a thickness of approximately 10 to 12 mm. Use a straight edge, trowel, and flow to ensure a uniform and smooth finish. Create suitable grooves or designs, if specified, on the plaster surface. Curing. Keep the plastered surface damp for at least 7 days by regularly sprinkling water, covering with wet gunny bags, or using curing